Alright, today we'll be looking at using the principle of superposition to find the current I in the circuit. So, the basic principle of superposition is that we short one of the voltage sources, or we short all but one, but in our case there's only two, so we short one voltage source, and then we solve for the current I in this case. So we'll solve for I1, as it is not the same I in the original equation because we have removed one of the voltage sources. So important to note where you're going to set ground to. In our case, I'm going to set ground at this node. It does not matter where you put it, but put it on the outskirts is typically best, or around one of the voltage sources, as to avoid confusion. So I'm going to be using node voltage method to solve for the current. You can use whatever the method you prefer, but in my case, I believe the voltage or node voltage would be easier. So we have the node voltage at V1, V2, and V3. And in my case, I'm going to have that all the currents are leaving the node. So it's important to note that the voltage at V1 is already known, as V1 is equal to 90 volts. V1 is equal to 90 volts. 90 volts. It's also important to know that we have a dependent source as VB, and so VB is equal to V1 minus V3. V is the voltage at V1 and the voltage at V3, which is the total voltage across this resistor. So V1 minus V3 is equal to VB. So with that, we are now ready to solve this. So we're going to first write our node voltage equations. So we're going to start off with the node equation for V at node V3. So we have that V3 minus V1 over 1K as this current. So V3 minus V1, which is given to us as 90. And that is all over 1K. And we're also going to solve, we also have V3 minus V2 over 4K. And V2 is given to us as 2.5 VB. And VB is given to us that we solve for is V1 minus V3. So V3 minus V2 or 2.5 VB, and that is over 4 kilo ohms. 4K. And for the finally, we have V3 minus 0 over 2K. Over 2K. And that is all equal to 0. And we also need to find the node equation for V2, and which we're going to solve for. So the node equation for V2. So at V2, we have V2 minus V1 over 2K is the current that is leaving the node towards V1. So V2 minus 90 over 2 kilo ohms equals to that current, plus the current I, which is leaving, so in our case I1, which is the current that is on this branch across the dependent source, I1, use lowercase I to avoid confusion, plus V3 minus V2 over 4 kilo ohms. 4 kilo ohms, not money sign, equal to 0. So those are our node voltage equations. So what other preferred method you use to solve for? Like, I prefer to use a calculator, and so the output from a calculator is shown to be that I1 is equal to 7.1 milliamps. 0.1 milliamps. I1 is equal to 7.1 milliamps. So we are not done for here. We need to solve for I2, which would be the current for this dependent source when the 40 volts is shorted, when the 90 volts is shorted and the 40 volts is regularly. So we're going to do this equation again, but in solving for when 90 volts is shorted. So we're going to short 90 volts, and solve for I, just like we did in the previous equation. So we're going to name our nodes V1, V2, V3. We're going to establish ground to be on this node, which in our case is also converges to this node as well, as there's no resistor in this branch. And so we need to solve for VB, which in our case VB is equal to V1 minus V3. And since we established ground to be on this node, V1 is equal to 0, so VB is equal to negative V3. Alright, so we're going to solve these equations. So we're going to establish our node equation. So the node equation for V3 is V3 minus 40 over 2 kilo ohms, or 2K. And that is this current that is leaving this node towards the ground. So, and also we have the current that is leaving V3 going to the node V2, which comes out to be V3 minus V2 over 4 kilo ohms. 4 kilo ohms plus finally V3 minus V1 over 1 kilo ohm. V3 minus V1 over 1 kilo ohm, so 1K. And all that is equal to 0. We also need to solve for the node voltage equations at V2. So node equations for the voltage at V2. So V2, we have V2 minus V1 over 2K for the current leaving this branch. So V2 minus V1 over 2K. And we also have V2 minus 0 over, we also have the current going through the dependent source, which is I2, which is the part of the current for regular I. And also, finally, we have V2 minus V3 over 4 kilo ohms, and all that is equal to 0. So those are our two equations that is needed to solve for I2. And so when we do this calculations, we find that I2 comes out to be 17.894 milliamps. And so for our total current is equal to, our total current I is equal to the current we found, I1 plus the current I2, and this comes out to be 25 milliamps. Right, so that is the principle of superposition. Practice at home, and good luck out there.